so that was really good. We're going to talk more about rats, because who doesn't love rats in Hawaii? Cameras, traps, endangered forest birds, and artificial intelligence, with my primary goal being to link these disparate topics together as we describe a project that we've been working on with the Hawaii Forest Bird Recovery Project and the State Department of Fish and Forestry and Wildlife since about January. So where in the world are we? We're in Hawaii. You know that because you're here. We're specifically in Hawaii. We are working primarily on the Alakai Plateau, where Hawaii Forest Bird Recovery Project has several larger scale rat trapping grids in place. So we are attempting to conserve Hawaii's forest birds, which face numerous threats, like invasive ungulates, invasive plants, human development, invasive mosquitoes that carry invasive diseases, perhaps you're detecting a theme here, invasive fungal pathogens that are just hurting the ohia tree and taking out some kind of keystone species. And then finally, we have our friend, the rat. So in terms of waging the war in Hawaii against rats, we are also using rat trapping grids, which I don't need to describe too much because Tyler did a great job of doing that. And it's in hopes we think that primarily the rats are preying on the nests of some of the forest birds, and so in hopes of decreasing the nest-based predation of females and juveniles, they are trapping rats in the Alakai. So Tyler did a great job of describing the problem in the field. The problem in the lab is that, and he kind of alluded to this, if you're trying to take pictures of anything that is small or cold or fast, or the tree is moving, you can end up with a whole bunch of photos. And so it's great when you have a whole bunch of photos of what you want to look at, which is rat behavior around these traps, in hopes of making them less risky to non-targets and more efficacious in terms of trapping rats. But it's not so great when you're the one sitting there with your finger on the forward button and playing yourself movies that look like this. Because watching plants grow is boring, no offense to the botanists. But it's also from an interpretation perspective, it's actually really pretty complicated because the way the light moves and the trees might move, and when you're doing this photo review as a human, you're sitting there and you're cueing on movement because you're looking at a time series that's the same. And so you're looking for something to move. Well, if there's all kinds of things moving, it's really kind of difficult. So it's an intriguing problem for artificial intelligence as well. And the problem in the lab is even more complicated than that, because what we're trying to work to do is train a deep neural network to not just sort one single photo series, but we are trying to have it pull out pictures that are meaningful from streams that really to the computer are going to look a lot more like that, where you've got all kinds of different animals, you've got different scenes, you've got different cameras in different locations, and you're trying to teach the computer, I want you to find me a rat. So how do we approach this problem of separating the signal from the noise? We use science, of course. In 1968, when 2001: A Space Odyssey came out, that movie did not have a very favorable rhetorical view of artificial intelligence. Hal was a villain who was trying to complete his mission at the cost of Dave's life. That is not a friendly character. The rhetorical perspective of AI now has become a little more balanced in kind of the current cinematography or whatever. And so, whereas before it was a villain, now it is something that we might rely on. It's still more intelligent than we are, but it's something that we might rely on to do things we can't do, like solve complex problems and fight alongside the Avengers to protect the Infinity Stone, like Vision. If you haven't seen Captain Marvel, you really should see it. But really, what is artificial intelligence? What am I talking about? We're training a deep neural network, which specifically looks like this. This is a graphical representation where you can take very complicated inputs over there on the left, like every pixel in an image, and feed them to get them down to an output where you might classify that image into rat, not rat. And in order to do this, there are some that can cluster, and they'll just do it on their own, cluster similar things on their own. In our case, we were providing training data. So we labeled the photos, this is a rat, this isn't a rat, and we fed it to the machine. And what we can do when we train these algorithms is tell it how many layers go in the middle. So there actually are just these complex mathematical relationships between each of those dots, which are nodes. And as the person who tunes the algorithm, you just kind of, you can tell it how many layers, and you can specify some things about the feedbacks and relationships between those layers, and then you let it run over iteration, and it learns when it doesn't get things right. And it goes back and corrects the relationship, kind of tunes the dialogue. And so we were able to using programming in R and using the package Keras with Python as a backend and interfacing with Google's TensorFlow, we were able to train an AI network, a deep neural network, to identify rats in complicated photos. And it was able to do it with data it had seen 92% of the time. So it was doing a very good job on data it was not entirely naive to. And that's about where we are. It was able to identify when the rat was there. It was able to identify the rat all the time. And when the rat, it sometimes misidentified saying there was a rat in the picture where we could see a rat. So I'm obviously not going to go through all this, and I'm getting lower on time, but I want to highlight a couple things that are important. The whole point of the Marvel Comics thing was the AI characters could be good or they could be evil depending how you trained the algorithm. And so that is a really important thing, is what are you feeding these things and how are you designing your study in the field and in the lab to train the algorithm to do the right thing. So one really important thing, we learned a lot in the field, so please reach out and get in touch with us about the field positioning of the cameras and moving them. In terms of the AI, it's really important to move the camera, because if you just train it on one site, it's going to learn everything about the image. And then if you try to move it to another site, it doesn't generalize well. Whereas if you're putting in training data from all of your sites, then you're teaching it what you want to teach it, not everything about that. So they are sensitive to, it's called overfitting. How much data do I need? I trained the RADOM AI network on 400 photos of each. It was important to balance those photos. So even though in reality I have many, many, many more empty frames because of some things we did in the field, I actually balanced them 400 and 400 when I trained the model. And again, I'm not going to drag you through all this, but there were a lot of nuts and bolts in terms of the field and in terms of the lab, in terms how we did things. Really, the main thing, I was kind of talking to Tyler about this, is it becomes a big data management project. You need to prepare yourself for collecting and managing and storing gigabytes worth of data and then processing it. When you go to train the network, it's actually not as data intensive, because the first thing you do is kind of dumb down the photos, you blur them. But anyway, that is it. Mahalo. I want to thank our partners on the ground, the state and Hawaii Forest Bird Recovery Project. This is very much in partnership with them, and also Good Nature has been really good about sending us things for examining the behavior of the animals around the trap. And I also want to thank our unseen partners. This would not be possible without TensorFlow, which is a product developed for training deep and convolutional neural networks by Google Brain and made open source online. Python and R also are free open source software, and we would not